All right, now in practice, whenever you differentiate functions, you do not want to go through the limit process every single time, right? It's important to know why the limit makes sense and that the derivative is defined as the limit of the slopes of secant lines, right? It is the slope of the tangent line, but you don't want to go through that limit process every single time. We're going to give ourselves shortcuts. So one of the shortcuts to finding a derivative is the power rule. So let's think right there. If you have x to the n and you want to differentiate with respect to x, then you can use this rule. So note, we are not allowed to differentiate something that looks like e to the x, right? Because the variable that I'm looking to differentiate with respect to is in the exponent. This power rule only works if the variable that you're looking to differentiate with respect to is being raised to some power. So think x to the 7 or 5x to the 4 or 3x cubed, right? The variable is being raised to some power. So as long as you have a power function, you can use the power rule for derivatives, which says that I'm going to take this in and I'm going to move it in front of the x value. And then I drop that power by 1. So that's the pattern. You move the power down in front as a constant multiple, and then you subtract 1 off of the power. So let's find the derivative of the power function. In fact, let's do this one. I know it doesn't say this. Let's do it in 2 different ways. First, with the limit, using the actual definition of the derivative, and then using our power rule. So by definition, the derivative is the limit as h goes to 0 of f at x plus h minus f at x over h. That's going to be limit as h goes to 0. So x plus h cubed is going to give me x cubed plus 3x squared h plus 3h squared x plus h cubed. I will then subtract off f of x, which is x cubed, divided by h. Right, so if it's not clear to you why x cubed plus 3x squared h plus 3h squared x plus h cubed is x plus h cubed, go ahead and pause the video and make sure that the algebra is clear. When you multiply x plus h by itself 3 times, you get what's there in red. Ooh, nope, there we go. Uh-oh, oops, what's happening? There we go. H goes to 0. Cancellation in the numerator, my x cubes are gone. And let's go ahead and factor out that h as well. You're left with a 3x squared plus a 3hx plus an h squared. Your h's cancel. You're left with a derivative, which is the limit as h goes to 0 of 3x squared plus 3hx plus h squared. When you send h to 0, you get 3x squared. Right, so that's using the limit definition of the derivative. Now let's use the shortcut that tells me that I can differentiate right? This is Leibniz notation, this is Newton's notation, but they mean the same thing. It's the derivative of the function f with respect to x. So it's the slope of the tangent lines to the function f of x. So if I have the derivative of x to the n comes down in front, and you subtract 1 off of that power. So the derivative of our function x cubed, the 3 comes down in front, and you subtract 1 off of the power. So 3 minus 1 gives you a 2, 3x squared, right? You get the same thing, except using the shortcut, using the power rule is a lot faster.